Hello there, thank you for joining me. My name is David Gator. This video we're going to add phasors together and we're going to be in quadrant 3. So quadrant 3 has negatives on the horizontal and negatives on the vertical. So got a lot of negatives to deal with, so we're going to be very careful with our signs when we put it into the HV chart here. Alright, so we're going to add everything together. We're going to take V1 50 volts at 200 degrees and add it to V2 70 volts at 260, and we'll expect a phasor somewhere down in here in between the two. All right, so let's take a look at what we got. V1 is 50 at 200. Okay, and then we have V2 70 at 260. All right, so take 50 volts times the cos of 200. We're going to get a negative 46.9. Of course, we expect a negative for both values. 50 times the sine of 200, we get negative 17.1. All right. Initially, we were expecting exactly what we expect, or we're getting what we expect, I should say. Negatives and negatives on the vertical and horizontal. 70 times the cos of 260, same thing, negative 12.2. And then we get 70 times the sine of 260, and that is negative 68.9. All right, so we've broken it down into its components. Now, in order to find out what V total is, we have to add up everything to their like values. So negative 46.9 plus negative 12.2 is negative 59.1, and negative 17.1 to negative 68.9 is negative 86. All right, perfect. Now we've got our triangle that kind of looks like that, and we're trying to figure out what our new hypotenuse is here. So we use Pythagorean theorem. Once again, that would be a squared plus b squared, and c is going to equal that. So we take in negative 59.1 squared plus negative 86 squared. We're going to get a positive value out for a total. And so then our new v total here is going to be 104.4 volts. Excellent. So if we just kind of eyeball things here, so we got 50 and 70, and we're adding them together. We expect a little more than 70, and about 104 sounds about good to me. So what is left is we got to figure out at what angle does this occur. So we just got to figure out where it lies in the plane here. All right, so we can take the tan function. That's the arctan minus 1 of the opposite over adjacent, which is vertical over hypotenuse, sorry. Vertical over hypotenuse. Sorry, I'm messing myself up here. There we go. So how about vertical over horizontal? That's what I'm trying to say, which is opposite over adjacent. Here we go. So we take those numbers. We take the arctan of negative 86 over negative 59. And what we get is, once again, it's an angle that we have to interpret. That's 55.5 degrees. Now, 55.5 degrees is up in this quadrant 1 somewhere, so we know we can't be up there. So what happened here was this was a negative, and this was a negative. And when we did that division before the tan function, it made the total a positive number. So the tan function had no ability to figure out whether in what quadrant it was. It's kind of a dumb function. We got to do the thinking. All right, so if we're 55 degrees, that's the angle from the baseline to where our new phasor is. So we're at 180 degrees on the line here, and we need to add 55 to it. So that gets us to 235.5 degrees. Okay, stuck to 55. We added 180, and now we have our new phasor with its angle. So 104 at 235. So at 180, 190, 200, 210, 220, 230. So somewhere about here. So we take this and kind of approximate. That looks pretty good to me. That's our new V total. And this here is the 55 degrees that we were looking at. 5 degrees, it was the angle in between there. But in reality, that V total sits at 235.5 degrees. Okay, so there we go. Quadrant 3, sorry, a little bit trickier. Everything's negatives. We've got to make sure we keep the negatives as they are. Adding a negative to a negative, we'll get a bigger negative, right? So we need to just be very careful with the way we go about solving these, any phasor really, but in quadrant 3 for sure. Okay, so I hope you enjoyed this video, and we'll see you in the next one.